Here is your trigonometry review, methods to solve triangles. We're going to start with the Pythagorean Theorem. When do we use this? It is a right triangle, I am given two side lengths, and I need to find the length of the remaining side. It's important to note that C represents the hypotenuse, which is the longest side length across in the right angle. This is my right angle. My hypotenuse is this side length. In the equation, C represents the hypotenuse. Another thing to note is if you need to solve for one of the other sides that is not the hypotenuse, you will need to rearrange the formula. For example, if I'm solving for side B, this will be my formula. Let's try an example. Calculate the length of x. First, I just want to indicate which one is my hypotenuse so that I don't get confused. If my right angle is here, then across from it is 20. So 20 is my hypotenuse. I'm trying to find x. I'm going to start by writing down my formula. A squared plus b squared equals c squared. Next, sub in the numbers that I know. Now, it doesn't necessarily matter if I put 16 and x as a and b. I just know that 20 has to be c because it's the hypotenuse. So I'll put in x squared for a squared, 16 squared for b squared, and 20 squared for c squared. My next step is just to simplify. 16 squared is 256. 20 squared is 400. I really want to get x by itself, and so in order to do that, I first need to move the 256. Because we're adding 256, if I subtract it, it gets rid of it. They cancel each other out. However, whatever I do on one side of the equation, I have to do on the other side. That leaves me with x squared equals 400 minus 256. If I simplify that, I'll just get x squared equals 144. I still need to get x by itself. Right now we have x squared. The opposite of squaring something is square root. So I'm going to do that to both sides. My square root cancels out my square, and I'm left with x equals the square root of 144. If I put that into my calculator, I get x equals 12. So the length of x is 12 units. Next, we have primary trigonometric ratios. This is another method for solving right triangles. We use this when it is a right triangle, I am given a side length and an angle measure, and I need to find an unknown side length. Or it is a right triangle, I am given two side lengths and need to find an unknown angle measure. Note, if you're solving for an angle measure, you will need to use the inverse of sine, cos, and tan. You can find these on your calculator by pressing the second function button. I remember my trig ratios by saying SOHCAHTOA, which I'll always write on my page so that I remember. That tells me that if I have opposite and hypotenuse, I'm going to use the sine ratio. If I have adjacent over hypotenuse, I'm going to use the cos ratio. And if I have the opposite and adjacent, I'm going to use the tan ratio. Remember, my hypotenuse is always across from my right angle. Adjacent means beside, so it's beside my reference angle. My reference angle is right here. And then I have remaining the opposite side, which is opposite the reference angle. Let's try some examples. In this first example, we're going to find a side length. Example 1, calculate the length of x. First I see this is a right-angled triangle, and it deals with an angle and a side. Therefore, I can use my primary trig ratios. I always start by writing down SOHCAHTOA. Now, I'll label my sides. If 15 degrees is my reference angle, then that means that x is beside it, so it is adjacent. 18 is across from my reference angle, so that is my opposite side. And as always, hypotenuse is across from the right angle. We don't have any information about the hypotenuse, so we're not going to worry about it. What we do have is our opposite and our adjacent. Now I look at SOHCAHTOA. Which one uses opposite and adjacent? In this case, it's the tan ratio. Start by writing down my formula. Tan theta, remember theta is just an unknown angle, equals opposite over adjacent. Now I'll sub in what I know. I know my angle is 15 degrees, my opposite is 18 meters, and my adjacent is x. That's what I'm looking for. Now x is in the bottom of this fraction. I also need to get it by itself. So the steps that I will do to get this by itself starts with cross multiplying. I'm going to put tan 15 over 1 so that I have fraction on both sides of the equal sign. Then I'll cross multiply. That leaves me with x times tan 15 degrees equals 18 times 1, which will just end up being 18. I still need to get x by itself, but right now it's being multiplied by tan 15. So to get rid of that, I'll have to do the opposite, which is to divide. And whatever I do to one side, I have to do to the other. These tan 15s cancel each other out. And what I'm left with is x equals 18 over tan 15. If I put this into my calculator, I'm going to end up with x equals about 67 meters. Make sure your calculator is in degree mode. Because our angles are in degrees. Let's try another example. This time, we're going to find the measure of an angle, angle A. I'll start by just labeling the angle I want to find. That will be my reference angle. Now, I know I'm dealing with an angle and a side, and it is a right triangle, so I can use my SOHCAHTOA, or my primary trig ratios. Always label your sides. 17 is across from the right angle, so it must be my hypotenuse. 15 is across from my reference angle, so it must be my opposite side. Beside the reference angle is adjacent, but I'm not concerned with that in this question, because I don't have any information about it. What I do have is my opposite and my hypotenuse, and I'm looking for my angle A. Which one uses opposite and hypotenuse? By SOHCAHTOA, I know it's sine. Start by writing my formula. Sine of my angle is going to equal opposite, because the O is first, over hypotenuse, because the H is second. Now sub in what I know. I don't know A, so I'll just put an A for my angle. My opposite is 15, and my hypotenuse is 17. I need to get A by itself, but right now we're doing sine A. The opposite of sine A is inverse sine. But whatever I do to one side, I have to do to the other. Now this inverse sine gets rid of the sine. And I'm left with A equals inverse sine 15 over 17. If I put that into my calculator, I'll get about 62 degrees. And that is my angle A. Let's move on. Now what happens if we don't have a right triangle? We can't use our primary trig ratios or the Pythagorean theorem. So let's introduce the sine law. When do we use it? Use the sine law when you have one corresponding angle-side pair and one more piece of information about the triangle. For example, you might have two angles in one side, and you need to find the length of an unknown side. Or you might have two sides and one angle across from one of them. You're looking for the angle that corresponds to the other side. We have two formulas here. My tip is to use the first one, the top one, when you're solving for a side. It just makes solving easier. And you use the bottom when you're solving for an angle. Now, when I talk about corresponding side-angle pairs, this is what I'm referring to. Angle B is across from side B. That's my corresponding pair. Angle A is across from side A, another corresponding pair. And angle C is across from side C, another corresponding pair. In class, we talked about these looking like dumbbells, so search for your dumbbells. Let's calculate the length of B. First, I'll check if I have a corresponding pair. I do. I have both pieces of information. Now I'm looking for B. Do I have more information about this one? Yep, I have the matching angle, so I can use the sine law. Since I'm solving for a side, I'm going to put the formula that has side on top. B over sine B equals C over sine C. Across from angle C will be side C. Now sub in what you know. Angle B is 70, C is 25, and angle C is 35. I want to get B by itself. To do that, I need to get rid of the sine 70. So, since it's being a divider, if I move it to the other side, it becomes a multiplier. This leaves me with B equals 25 times sine 70 over sine 35. When I put that into my calculator, I get B equals about 41 centimeters. Let's try one where we have to find the angle. I have a corresponding side angle pair. I'm looking for angle B. Angle B is over here. Do I have another piece of information that will help me find angle B? Yep, I have the corresponding side, so I can use the sine law. Since we're looking for an angle, I'm going to put the angle on top, sine B over side B. Side B is just across from angle B. Side A is across from angle A. Let's sub in what I know. I need to get B by itself, so first, I'll take the 6.4 that is being a divider, and I'll multiply both sides by 6.4 to get rid of it. You can also just cross multiply. Since this is a divider and this is a multiplier, they cancel each other out. And whatever we did to one side, we had to do to the other. Let's rewrite this. Sine b equals 6.4 times sine 80 over 10.2. I still need to get my b by itself. But right now we have sine b, so we have to use inverse sine to get rid of it. I'm going to take the inverse sine of the entire other side. That leaves me with b equals sine inverse 6.4 times sine 80 over 10.2. And close your bracket. You can just solve the inside of the bracket first and simplify that to get a decimal. Make sure you leave at least 4 decimals if you're not finished the question yet. Or, if you're comfortable, you can put it all into your calculator at once. My final answer is about 38 degrees. Here is our last method for solving triangles. This is the cosine law. We use the cosine law when we have either 2 sides and the contained angle, and we're looking for the other side, or we have 3 side lengths and we're looking for an angle measure. Remember, this is when we do not have a right angle. If we have a right angle, we'll use either the Pythagorean Theorem or our primary trig ratios. One tip I had in class for you was to look for the Pac-Man or the alligator. We're going to use the top formula if looking for a side length, or the bottom formula if looking for an angle measure. Recall, this side length here has to correspond to the angle here. Similarly, this angle here corresponds to the one that we're subtracting. So, for our example here, we have side B, we have side A, and we are given angle C. That means we can find side C. Do you see the Pac-Man? Let's try an example. In our first example, we're going to calculate the length of B. So I have this side here, I have another side here, and I have the contained angle. That means I can use cosine law to solve for B. Since we're solving for a side length, we'll use the top formula. Remember, this side length that I'm looking for has to correspond to the angle. Now typically, across from my angle A will be my side A, and across from my angle C will be my side C. Let's sub in what I know. B squared equals 20 squared plus 16 squared minus 2 times 20 times 16 times cos of B, which is 52. Let's simplify. 20 squared equals 400. 16 squared is 256. Now I'll simplify just this part here. 2 times 20 times 16 is 640. And I'll leave the cos 52 as is for now. Recall, if we have like terms, we can combine them. 400 and 256 can be added together because of this. So b squared equals 656 minus 640 cos 52. I can't subtract yet because I still have 640 is being multiplied by cos 52. If I put that all into my calculator, I'm left with b squared equals approximately 261.98. Now I'm not done yet. Don't forget, we need b by itself completely, but it still has that square there. So I have to use the opposite of squaring, which is square root. And I'm going to do that to both sides. The square root cancels out the square, leaving me with b equals the square root of 261.98. And I get that b equals approximately 16.2 centimeters. One more example. Let's find the measure of angle A. Now we don't have a right triangle that we know of, but we do have all three sides. That means we can use the cosine law to solve for an angle. Since we are solving for angle A, we need to make sure that we have the corresponding angle and pair in our formula. Okay? Let's label these sides. Across from angle C is side C, and across from angle B is side B. Let's use the second formula because we're finding an angle. A equals cos inverse of b squared plus c squared minus a squared over 2bc. Make sure you have angle A and side A are in those two spots. These first two numbers that are being squared and added together are the sides that are containing angle A that we're trying to solve for. Let's sub in what we know. B is 38, C is 26, and A is 30. I'm going to put that over 2 times 38 times 26. Let's simplify this a bit. 38 squared is 1,444. 26 squared is 676. And 30 squared is 900. That's divided by 2 times 38 times 26, which is 1976. If I add up that top, I get 1,220 divided by 1976. Now I can put this into my calculator. Make sure you use cos inverse. And I get that A equals about 52 degrees. And that's my final answer. Now remember, if I ask you to solve for a triangle, you have to give me all of the unknown sides and all of the unknown angles. This was just an example how to find one angle. That's all for today. Hope that helped.